Great, now let's go to video 2. Video 2 of the series is called Simplifying Radical Expressions, some of which include I. So, first, I think it helps to know that you need to have 0 squared all the way down to 15 squared memorized. All the way down to 15 squared. Whoa, that is totally opposite. 15 squared. The reason are that these tell us the perfect squares. And you know that's 0, 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, all the way down to 15 squared, which is 225. We need to have those memorized because it makes simplifying radical expressions so much easier. In the sake of keeping videos short, I'm not going to list them all out. You can do that yourself. So let's take a radical expression. Let's go with negative 36. And I am going to make that a radical. So normally, if there wasn't a negative there, we would just say, what's the square root of 36? And it's 6, remembering that any time that you take a radical, you do plus or minus 6. But now that we got this negative in there, we need to rewrite this as two radical expressions, one of them being negative 1 and the other being 36. Now, if you remember from the last video, anytime that you see an I squared, substitute negative 1 and vice versa. When you see a negative 1, you can substitute I squared. So the square root of negative 1, well, if I change that to I squared, anytime that you take a square root of something squared, you just get itself, right? The square root of x squared is x. The square root of 2 squared is 2. Because 2 squared is 4, and the square root of 4 is 2. So anytime that you're going to get a negative 1, it's eventually going to be I. You can memorize that if you would like to, or you can just see how it breaks down, and that negative 1 is I squared, and the square root of something squared is I. Now we can break down this one. The square root of 36 is 6. So now that these are multiplied together, these have to be multiplied together. We get plus or minus 6I. Fantastic. But it's not always going to be that easy. See, this was a perfect square. I'm going to do it in green because green is pretty. But sometimes we're going to have stupid numbers like negative 40. And we're going to have the square root of that dumb number. So we're going to do it the same way. Negative 1 inside of a square root. Let me rewrite that because that was terrible. Square root of negative 1 and square root of 40. Now, to simplify 40, you're not going to punch into your calculator and give me a decimal, but you notice it's also not a perfect square. So what we're looking for is one of these perfect squares that I want you to memorize. Do any of them go into 40? Well, most commonly people want to say, oh yeah, 2. Well, guess what? 2 is not over here. 2 is not a perfect square. If you plug in the square root of 2 into your calculator, you do not get a nice integer number. You get decimals. But if you look, what do we have here? Oh man, 4 is a perfect square and it goes into 40. So we're going to rechange that to the square root of 4 times the square root of 10. Now, why would I do that? Because it's the biggest number. 9 doesn't go into 40, 16 doesn't, 25 doesn't, all the way down to 225 does not go into 40, but 4 does. And the reason that we do this is now we know the square root of negative 1 is going to become I, and we know the square root of 4, is going to be 2, and we know we can't simplify square root of 10 because none of these numbers go evenly into 10, so we leave it as square root of 10, and so now when we combine this all, we get plus or minus 2I square root of 10. So simplifying radicals, big time skill. You need to know how to do that. If you need some practice, you're going to have to Khan Academy or YouTube or Google it or something. The only other thing I'm going to show is what's called rationalizing a denominator. And this is kind of a weird subject, but it happens and you need to know how to do it because we could get some I's in there a little later on and it's done sort of similar. So if I have let's draw it. It's going to look sloppy, but that's okay. 5 over square root of 2. And I got to get this radical out of that denominator. So to do that, I'm going to multiply it by square root of 2 over square root of 2. Because that's the method, that's how you do it. And that's because 2 times 2 is 4, and the square root of 4 is 2. This is going to work every time. So 5 square root of 2, and 2 times 2 is 4, so I have the square root of 4. The cool thing is that the square root of 4 simplifies out to 2, and now this can't simplify anymore, so that's my answer. Great. If it could simplify, like let's say this was 10, then I would have 10 square root of 2 over 2. The 10 over 2 would simplify to 5 over 1. What I mean is, let's look at this example, slightly different, so we'll do it in blue. 5 over 2 plus square root of 2. Oh, that looks a little bit different. So we're not going to multiply by square root of 2 over square root of 2. We're not going to multiply by 2 plus square root of 2 over 2. In fact, we're going to multiply by what's called the conjugate, which is opposite. So 2 minus square root of 2. And you do that over itself. And the reason that we do that is, if you remember the perfect square trinomials that we dealt, or the difference of two squares, we are going to have a plus answer and a minus answer, because that way we are left with the 2 squared and the square root of 2. And I'll show you what that means when we distribute this out. So we have to do just that, distribute. So 5 times 2 is 10, and 5 times negative square root of 2 is minus 5 square root of 2. And we put that under, or over, we distribute this. 2 times 2 is 4. 2 times negative square root of 2 is negative 2 square root of 2. 2 square root of 2 times positive 2 is positive 2 square root of 2. And then lastly, square root of 2 times negative square root of 2 is minus square root of 4. Now we simplify. These two things cancel each other out because they're like terms. It would be like saying negative 2x plus 2x. That would be 0. Negative 2 square root of 2 plus 2 square root of 2 is 0. So it leaves us with 10 minus 5 square root of 2 over 4 minus, well, if you look, square root of 4 is 2, so 4 minus 2. Final answer, 10 minus 5 square root of 2, all of that over 2. Now look, 10 over 2 can simplify, but 5 over 2 can't. And so since it can't be simplified any further, we can box it off like that. And that is an answer that we can do. And that works. You will likely see it split apart into the two fractions. 10 over 2 minus 5 square root of 2 over 2. Because you know that. You can write this as two fractions. 10 divided by 2 minus 5 square root of 2 divided by 2. And now we can see how this simplifies to 5. And so you may see it as 5 minus 5 square root of 2 over 2. Oh, goodbye.